So 2.4 constant acceleration with formulas. Gradient of velocity time graph gives you the acceleration, and as we summarize the formulas, few of them are: displacement equals velocity into time, velocity is equals to initial velocity plus acceleration times time, or s equals ut plus half at squared, and v square minus u square is equals to 2as. Example question: a cyclist is traveling along a straight road. She accelerates at a constant rate from a velocity of 4 meters per second to 7.5 meters per second in 40 seconds. So initial velocity is 4, final velocity is 7.5, time is equals to 40. Find the distance she travels. So if we have a look at the formulas, we can see that the average velocity is initial velocity plus final velocity by 2, that is 4 plus 7.5 by 2, 11.5 by 2, and if you multiply the average velocity into time, you will get the displacement, and time is 40. So 230 meters is the distance covered. B part says her acceleration in 40 seconds. Acceleration is change in velocity over time taken. So change in velocity over time, final velocity 7.5, initial velocity is 4, time taken is 40. So that is 3.5 by 40. Okay. Okay, moving towards questions. Is this the one? Later with the marks. Yeah, okay, with the marks. Okay. Question number 9. A skater traveling in a straight line uphill experiences a constant deceleration. At the bottom of the hill, the skater has a speed of 16 meters per second, and after moving up the hill for 40 seconds, he comes to rest. Find the deceleration. So we have the initial speed, final speed, and time. If I use the formula for acceleration, that is final velocity minus initial velocity divided by time taken. So my final velocity is 0 because it comes to rest. Initial velocity is 16 at the bottom of the hill. Time taken is 40 seconds. So minus 16 by 40. Let me use my calculator. So 16 by 40 is 0.4. So if my acceleration is negative 0.4 meters per second square, my deceleration should be positive 0.4 meters per second square. B part. The diagram from the bottom, the distance from the bottom of the hill to the point where this guy comes to rest. So this is our case. Speed here was 16 meters per second, at top was 0 meters per second. The time taken to travel this distance was 40 seconds. So if I use this formula, distance equals velocity into time, where velocity would be average velocity. So initial plus final by 2 is 8 meters per second is the average velocity. Time taken in 40, 8 4 times 32, and there this goes 0 meters. Question 10. A particle is moving in a straight line with constant acceleration. The points A, B, and C lie on this line. The particle moves from A to B to C. The speed of the particle at A is 2 meters per second. The speed of particle at B is 7. The particle takes 20 seconds to move from A to B. Find the acceleration of the particle. So we have this information and we have the time. And acceleration is straight away plug in the formulas. Final minus initial by time. Final velocity minus initial velocity divided by time taken. So that's 5 by 20, which is 1 by 4 equals 0.25 meters per second square. The speed of the particle at C is 11 meters per second. Find the time taken for the particle to move from B to C. Now, if we just summarize, this was A, this was B, this was C. From A to B, speed at A was 2, then 7, then 11. This time right here is 20 seconds and the acceleration is 0.25 meters per second square. Now speed at C is 11 and we need to find the time. We already know the acceleration of the particle. So if I use this formula, acceleration is final minus initial over time taken. I know the acceleration, which is 0.25. Final velocity, which is at C, is 11. Initial velocity, which is at B, is 7. And the time is unknown. So we cross multiply. 11 minus 7 is 4. 4 divided by 0.25. And we get 16. So T is equals to 16 seconds from B to C. The distance between A and C. This is A, this is C. And if I say speed here is 2, speed at the end is 11. And I know the total time, which is 20 and 16 seconds. That is 36 seconds. So we can use this formula. Distance equals velocity into time, and average velocity would be 11 plus 2 by 2, and total time taken is 36. So 13 by 2 times 36, and the distance is 234 meters. So if we check it with another formula, which was S equals ut plus half at square. So initial velocity for this C part is 2 and time is 36 seconds plus half. Acceleration, we solved that in first part, that is 0.25, and time again 36 squared. So when you simplify it, you again get 234 meters. So whatever formula you use, you'll get same answer. Question number 11. A particle moves in a straight line from A to B with constant acceleration. It then moves along the same straight line from B to C with different acceleration. The speed of particle from A is 1 meter per second and the speed of particle at C is 43. The particle takes 12 seconds to move from A to B and 10 seconds to move from B to C. Find the speed of particle at B. Let me open a different writing space. And quickly note down the given data. This is question 11, exam style question. Particle at A, at B, at C. The particle moves in a straight line from A to B at constant acceleration of 1.5 meters per second. So from A to B is 1.5 meters per second square. Acceleration is given. It then moves along the same straight line from B to C with a different acceleration, and the new acceleration is 8 meters per second square. The speed of particle at A is 1 meters per second. This is 1 meter per second. Speed of particle at C is 43 meters per second, and the particle takes 12 seconds to move from A to B. Time equals 12 seconds, and 10 seconds from B to C. This is 10 seconds. Okay, we're done here. So the speed of particle at B. So I know the acceleration. So acceleration equals final velocity minus initial velocity divided by time. Acceleration is 1.5. Final velocity at B is unknown. Initial velocity at A is 1. Time taken is 12 seconds. So we cross multiply. 12 into 1.5 is 18, is equals to V minus 1. 1 goes on the other side, gets added. So velocity at B is 19 meters per second. 19 meters per second. A part done. B part says the acceleration of particle as it moves from B to C. A part, B part. Acceleration when it moves from B to C. So acceleration is final velocity minus initial velocity divided by time. Final is 43, initial is 19 for this section, and time taken is 10 seconds. So 43 minus 19 is 24 by 10. That gives you 2.4 meters per second square. So this acceleration is 2.4. C part says the distance from A to C. So the distance from A to C, we'll solve this in two different sections because the rate is different. So distance is equals to velocity into time, and definitely because it is accelerating, we'll be using average velocity. So that is initial plus final by 2 into time taken 12. For the second section, it is again initial plus final by 2 average into time taken, that is 10. So 19 plus 1 is 20 by 2, 10 into 12, 120. 19 plus 43 is 62 by 2, 31 times 10 is 310. So 120 plus 310 is 430 meters. Any confusion? Cyclist traveling with constant acceleration x meter per second square in straight line from rest to 5 meters per second in 20 seconds. She then decelerates from 5 meters per second to rest with constant deceleration 1 by 2x meters per second square. Find the value of x. Okay, so first we need to find x. A cyclist traveled with constant acceleration in straight line from 5 to 10. 0 to 5 in 20 seconds. So acceleration is v minus u over t. Final velocity is 5. Initial is 0. Time taken is 20. So acceleration is 0.25 meters per second square. Then it says the total distance she traveled. So we know the rate, and I like to sketch a graph here. It travels from 0, attains a speed of 5 meters per second in 20 seconds, and then the rate of retardation is actually half. So that would take another 40, making it 60 seconds. And the total distance is actually the area under the graph. So 1 by 2 base times height. 150 meters. Clear?